Okay, now I'm going to address question 5 here, which is what is the value that a multimeter hooked up as an ammeter will show for I2? So what is I2 really is this question. And I think on the exam a lot of people were tripped by the question because this current is in the same direction as the voltage drop is indicated here. But these are, I'm going to say the word independent, almost independent, because these are two different questions. So for this question number 5, I'm going to forget this one. I'm going to think, okay, you know what? Natalia is making it wrong here, but I'm going to leave it be. So I just want to look at I2. So I2 in the circuit. So what happens is this 5 volts, these 5 volts are shown with this polarity here. So when there's a plus on this side, turns out there is a voltage drop there, which in the previous video we just figured out it was 125, I think. And because these two resistors are in series, what happens is there is a voltage drop in that same direction. This way here, this green is 3.75. So what happens is those 5 volts split up in the same proportion as the resistance. 300 is 3 times bigger than 100. 375 is 3 times bigger than 125. And now you can absolutely use Ohm's law and say, you know what, V equals IR, and therefore V divided by R is that current I2, and it's in the right direction. So it's I2, and this will be 375 divided by 300. And we sort of know that 375 divided by 3 is 125. But I want to put this in milliamps, so I'm going to write 12.5 milliamps. Could have also done 5 volts divided by 400 ohms. It's the same current. It turns out this 12.5 milliamps is also going through this resistor here, and you see how it's following the passive convention. So the current's going to go to the right side. This I here, it's also I2, while the voltage drop is on the other side. It's going the other way. Same thing here. This minus V2 and plus V2 was just how my multimeter was connected for question number 4. I hope this helps